Hey, good morning, everybody. How are y'all doing today? Did y'all have a good Thanksgiving? Yeah? Eat lots of turkey and stuffing? All right. Well, I guess we're being quiet this morning. Well, I hope everybody had a good Thanksgiving. I know I did. It was nice to have some days off. Um, where I didn't think a thing about school. But we're back at it. Um, we have the next 2 weeks of in-class material, and in those 2 weeks, we'll get some time for reviewing for the final exam. Um, I wonder if I should have some more problems for this homework set. Maybe. Um, I've set aside today and Wednesday for assignment 23. I don't know if we necessarily need 2 days to do it. We'll see how today goes. We're dealing with matrix solutions to systems of equations. Um, so I've asked you to at least have looked at the notes for this homework set, and perhaps you are working on the homework. Perhaps you finished the homework. Whatever the case may be, my only agenda for today is to address any questions that you have over this homework set.
Mr. Clopton,
Yes, ma'am.
how can I still receive credit since I am not able to write as much?
Hey, Lizeth, how do you pronounce your name?
Lizeth.
Lizeth.
Mhm.
I'm getting tongue tied over that, but I'm going to do my best. I sent you some emails. Um, I know that I saw that you had emailed me over the weekend, and sorry I didn't reply, but I was just not. I didn't even look at my computer till just now. Um, I would say do your very best. As far as the homework goes, um, I would just work on the homework, and just do your best. Um, do what you can. I know it's going to be hard if you can't really write with your hand, with your right hand. I would say just do your best, and help me remember when I'm grading. Just say some note for me, just reminding me of your situation. Okay?
Yes, sir. Thank you.
Um, yes.
Um, on Blackboard for week 14, it has assignment 23 in the notes, so that one's fine. But then it skips assignment 24 and goes straight to 25, but 25 only has an assignment and not notes.
All right. So we have. Okay. Um, okay. And I see that. So that is. Thank you for bringing that to my attention. Um, Okay, I will, so thank you, number one, thank you for bringing that to my attention. Assignment 25 does not have, n- notes attached to it. So, um, one of two things is gonna happen. The first possibility is that, let's see, that was Thanksgiving break. Today is Monday. I'll either get the notes made plus lecture videos, or, um, on Monday, or not Monday, but Wednesday or Friday, probably Wednesday, we'll do a traditional lecture where I just go over some examples of what this assignment is about, and we'll just do a traditional lecture. So either I get the notes made, videos made, and all that stuff, or um, we'll do a traditional lecture on Wednesday. Um, I imagine, just because we're in the midst of the semester and I have other things on my plate, that we're just going to do a lecture on Wednesday over assignment 25. So you can just kind of bookmark that and say that's what's happening on Wednesday. Um, but if I get the notes and videos made, then I'll do the notes and videos. So that's what I can say about that. Thank you again for bringing that to my attention. Okay. So, let me just change the course of questions. Um, how's assignment 23 going? Have we started it? Are we working on it? Do we have any questions? Um, what are we at with assignment 23?
We've all started the homework.
Okay. So, are y'all just working on it at this point?
Yes, sir.
Okay. Anybody else?
We're starting it also.
Okay. Well, in that case, I'll just sit back, get some work done, and let y'all work on the homework. If you have any questions that come up, um, let me know, and we'll go from there. Hey, just checking in. How's everybody doing? Any
We're doing
questions?
good.
Doing good?
Do you mind doing number 2?
Sure. Number 2. We have the system 4x plus 3y equals 15, 2x minus 5y equals 1, and part A just says to write the augmented matrix for the system. So all we're going to do is we're just going to write down the coefficients and the constants in columns and rows. So we have 4, 3, so that's the coefficient for x, the coefficient for y, and then we use this vertical bar to represent the equal. A equals 15, and then 2 minus 5, and that equals 1. Now, there is lots of different avenues that you can go down for solving these systems. It's kind of how you pick and choose to do things. Some of y'all might decide to swap row 1 and row 2. It just depends on what you want to do. So you can do one or two things that we want to have happen. Is we want this to be a 0, and we also want this to be a 1. So if you make this a 1 first by dividing this row by 4, or you go through and make this a 0, it really doesn't matter the order that you do things in. So what I think I'm going to do is, for no real reason, I'm going to choose to make this a 0. And the way I'm going to do that is I'm just going to write my instructions over here. I'm going to do negative 2 times row 2 plus row 1. So, number 1, since I write my instructions in line with this row 1 does not change. Now, here's where we do the math, and I'm just going to do this mentally. Negative 2 times row 2, so negative 2 times 2 is a negative 4, added with 4 is 0. Negative 2 times a negative 5 is a positive 10, added with 3 is going to be 13. Negative 2 times 1 is a negative 2, added with 15, that's a 13. Alright, now this would be really easy to get this to be, because I want to do one quick thing. I always like to remind myself of what is my goal. My goal is to get 1, 0, 0, 1, and then I'll just call this A and B. I want a diagonal of 1s, and I want zeros below and zeros above that diagonal. So you can see that we've gotten the 0 right here. Now we need this to be a 1. Well, this is really nice because all I have to do to make this a 1 is I can just go through and I'm going to write it like this: 1/13 of row 2, or that's just simply saying row 2 divided by 13. So now we get 4, 3, 15, 0, 1, 1. Okay. Now I need to go through and I need to think about a couple of things. I still need to make this a 1, but I also want this to be a 0. And I think right now it's going to be easier to make this a 0 rather than making this a 1, because if I make this element right here, this 4, a 1, that would mean I have to divide row 1 by 4. Well, that's going to introduce some fractions. And I really don't want to deal with fractions, so I'm going to work to make this 3 a 0. And how am I going to do that? What if I take negative 3 times row 2 and add it to row 1? And so this is just the way I do my notations. I keep my instructions in line with the row that I'm working on. I mean, you see different people do it differently. It's just the way I do it. So row 2 does not change. So here we do the math. Negative 3 times row 2, so negative 3 times 0, plus row 1, that's still going to be 4. Now negative 3 times 1 is a negative 3, plus a positive 3 is 0. And then negative 3 times 1 is a negative 3 plus 15, that's going to give me 12. And now it's going to become really easy to make this element a 1, because I can see already that by dividing this by 4, I can also divide 12 by 4. So if I take 1/4 of row 1, a fourth of 4, 4 divided by 4 is 1, 0 divided by 4 is still 0, 12 divided by 4 is 3, and then I'm not doing anything to row 2, we get 0, 1, 1. And now that this is in Gauss-Jordan, Gauss-Jordan means that you have a diagonal of 1s, zeros below and zeros above that diagonal. We can immediately start saying things like this: that x is equal to 3 and y is equal to 1. So that leads us to the solution 3, 1. Now, before I open the door for questions, I just want to make a quick comment. It would have been perfectly fine to divide row 1 by 4 at the beginning, and maybe even thinking about dividing row 2 by 5 at the beginning. You'll definitely introduce some fractions, but at least you'll have the 1s here and here. I don't know. I like to do anything that I can to avoid getting fractions. So that's why a lot of times getting my zeros in place, as I start to get this element right here to be 0, things just kind of start unfolding. 13 and 13 can both be divided by 13. And then as I work to make this 3 a 0, then things start falling into place. Oh, now I got 4 and 12. Both of those can be divided by 4. All right, so specifically to the person that asked that question, but then also to everybody, does the process that I went through, were you able to follow along, and did it make sense?
Um, I understand it, but it's really confusing on how like to know when to add or multiply.
So this is this is one of those um, this is one of those problems where your critical thinking is really going to come into play. A lot of the problems that we've done in the past have this very nice um, set of procedures that you kind of follow through. Oh, we set the equation equal to 0. Oh, we square root both sides, or you know, and the things that we've done in the past, they have a very nice um, method, set of procedures that you can follow to do things. This isn't really the case. This is going to be one of those things where you got to do some critical thinking. There's going to be some trial and error. You're going to try something and it may not work, or you may not like where it's going, so you're going to have to reset. I wouldn't necessarily erase your work. Grab another sheet of paper and start again. That way you can refer to things that you've already done. So it's just going to be a trial and error. So one of the things that I like to do in my face-to-face classes is I like to, let students try things on the board, or they tell me what to do, and we can talk our way through it together. So I'd be more than glad to do another problem where I have you kind of give me suggestions, and I'll see where things go with that. But it's going to be very much a trial and error, and that's just the way it is. So, yes, I'm smiling because this is good stuff.
Okay, that makes sense. Okay, thank you.
You're welcome. I would take this suggestion in mind. If what you're doing is introducing fractions, now fractions can't always be avoided, but if there's an alternative route to go down, if there's something else that you can do, maybe try that instead. I'm not going to tell you that fractions never occur, because they do, but see if there's a route that you can go down that does not introduce fractions. Excuse me. All right. What else can we look at? Any other questions? Just working through things. Excuse me.
Number 4.
I'm sorry, what?
Can you do number 4?
Sure. So that's a 3 by 3. I could do it in 10 minutes, but if I did it in 10 minutes, I would not be explaining things very well. So we'll just do what we can. Alright, I'm just going to go right into the augmented matrix. I think that's probably pretty straightforward. So the first row, my coefficients are 3, 1, -1, and then that equals 0. Second row is 2, 3, -5, and that equals 1. And third row is 1, negative 2, 3. And that equals negative 4. Okay, so let's keep our goal in mind. Our goal is to get 1, 0, 0, 0, 1, 0, 0, 0, 1, and then A, B, C. Okay. So, in terms of I guess you could say, what's the first thing that we want to take care of? Oops, that's not right. I want the highlighter. The first thing that I would consider getting taken care of is getting that 1 right there. Now, this is where this is why it's not going to happen in 10 minutes. Does anybody have a suggestion of what we could do to get a 1 right there, element 1 of row 1? Anybody have a suggestion? Let me put it this way. If I were to turn that 3 into a 1 by division, I would introduce fractions. Do I want to introduce fractions? Yes or no?
No.
No, I don't want to introduce fractions. So, what else could I do?
Oh, can you swap?
Yes, you can swap. Yes, you can swap. Yeah, it's perfectly fine to do. So, here's my very fancy notation for swapping. I'm going to just say swap row 1 and row 2. Or excuse me, row 3. So this becomes 1, negative 2, 3, negative 4. We'll leave row 2 where it's at. 2, 3, negative 5, 1. And then row 3 becomes 3, 1, negative 1, 0. So yes, you can swap. Alright. So we met our first criteria. Get that to be a 1. Now the next thing that we want to do is we want to make zeros below that 1. Now, we don't want to divide through by 0. That's not what we want to do. We want to think about adding, subtracting, doing row operations. So let me just give you what I would do. Let's talk about this 2 right here. I want that 2 to be a 0. I like the fact that this is a 1. So what I could do is I could do negative 2 times row 1 and add it to row 2. So let's see what that does. Now, because I'm writing my operation in line with row 2, that does not mean I'm changing row 1. So I'm just going to still have 1, negative 2, 3, negative 4. Now let's do this mentally. I mean, you can do the side work off to the side if you want to, but I like to do it mentally. Negative 2 times row 1. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 2 is 4, plus 3, that's going to be 7. Negative 2 times 3 is a negative 6, plus 5 is negative 11. And negative 2 times a negative 4 is 8, plus 1, that's going to be 9. Alright, so you see how we got that to be 0? Now somebody suggest to me a row operation to make that third 0. I want to make this 3 become 0. Somebody suggest to me a row operation that will do it.
Would it be negative 3r2 plus r3?
Not R2. So if you're going to use row 2 and 3, you got to have a common multiple between 2 and 3, which would be 6. So you'd have to do negative 3 times row 2 plus 2 times row 3. That's just too much work. Why don't we use row 1 again? What if we do negative 3 times row 1 plus row 3? So, I'm just noting, you said negative 3 times row 2. Maybe you meant to say row 1, but I'm just dealing with what I heard. Does this row operation make sense?
Yes.
So, here we go. Negative 3 times row 1. So, negative 3 times 1 is a negative 3 plus 3 is 0. Negative 3 times negative 2 is a positive 6. Plus 1 is 7. Negative 3 times 3 is a negative 9. Plus negative 1, so negative 9 plus negative 1 is a negative 10. And then negative 3 times 4, negative 4 is a positive 12 plus 0, that's going to be 12. Okay. Now, a couple of things that you can think about coming up next. Yes, we want a 1 right there in the middle. We want that to be a 1. I don't like the idea of dividing through by 7 because then I introduce fractions.
Your conference is scheduled to end in 2 minutes.
Now, at the same time, I also want this to be a 0. I want a 0, the second element of row 3. And what's nice about my current situation is, since I have the same coefficient here and here, I could just subtract to get my 0 right there. So here's my suggested row operation. Take row 3 and subtract from it row 2. So you get 1, negative 2, 3, negative 4. Now, row 2 is not changing, so that's still 0, 7, negative 11, 9. Alright, so think subtraction. 0 minus 0 is 0. 7 minus 7 is 0. Now, be careful how you think about this. Negative 10 minus a negative 11. Negative 10 minus negative 11, that's the same thing as negative 10 plus 11. That's 1. And then 12 minus 9 is 3. Okay. So we're almost to our diagonal of 1s. Again, I don't
Your
like
conference
to
is
think
now
about
over.
dividing by.
Goodbye.
So we'll have to pick up here on Wednesday. We'll pick up here on Wednesday.